whatever you have taken di, that is in the formula, you can also take it as yi, because yi is nothing but deviation of an assumed mean divided by the class size, that is height of the interval. So coefficient of variation is nothing but CV. It is given by the formula sigma divided by x bar into 100. Mean is always summation fi xi divided by n. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we are going to discuss another shortcut method to find the variance and standard deviation and also coefficient of variation. So I said we have one more shortcut method to find the variance and standard deviation of a given data. So the formula used to calculate the variance is sigma square is equal to h square divided by n square into n into summation fi yi square minus summation fi yi whole square. Okay, so this is the variance, and if you take the square root of this formula again, you will get the standard deviation. Here yi is xi minus a by h. So in this formula, h represents the size of the class interval and a represents the assumed mean. We will take any one of the observation as an assumed mean. We will calculate yi by h. Each observation we will calculate the deviation and divide by h. So here yi represents the deviation. So using that formula, we can calculate the variance and standard deviation. Let's look at the problem. Find the mean and standard deviation using shortcut method. So we have the class interval from 0 to 30, 30 to 60, 60 to 90, 90 to 120, 120 to 150, 150 to 180, 180 to 210. And frequency as 2, 3, 5, 10, 3, 5, 2. Let's look at the table which we are going to calculate here. So I have taken the class interval here and I have taken the frequency. So if you add all the frequency, you will get the value n is equal to 30. The next step is we have to take the midpoint. So take any midpoint from 0 to 30, the midpoint is 15. And here it is 45. Here it is 75. Here it is 105. Here 135. Next we have 165. Next we have 195. So these are the midpoints. So here what we conclude, we will take any one of the midpoints as an assumed mean. We will consider it as A. Okay. Let me take A is equal to 105. I'll take the mean will be 105. What is the height of the class interval in each class here? So that is 0 to 30 means height is equal to 30. Next, we want to calculate the deviation. How this deviation works here? Di is actually here assumed mean. Sometimes you can take it as a small a also. So you have to subtract each observations from assumed mean and divide it by h. That is 30. So therefore, what happens here? It is xi minus 105 divided by 30. You have to do for all the observation the same thing. For example, 15 minus 105, which becomes minus 90. Minus 90 by 30 becomes minus 3. Similarly, 45 minus 105 divided by 30, which becomes minus 60 by 30, which is minus 2. Similarly, here you will get minus 1 because you will get the difference as 30. Here 105 minus 105 is 0. So 0 by 30 is 0. Similarly, if you go on calculating each deviation, you will get this. Now this is the deviation, what you will get. Let us square it. So the next column is to square 9, 4, 1, 0, 1, 4, 9. Now we have di square. Let us calculate two columns. One is fi into di. Another one is fi into di square. First, let us calculate fi into di. So, we have both negative and positive values. So, first 2 into minus 3, minus 6. 3 into minus 2, minus 6. 5 into minus 1, minus 5. Next 0 you will get 3 into 1, 3. Similarly 5 into 2, it is 10. Next you have 2 into 3, it is 6. So when you add all this, minus 12, minus 17, then it is plus 19. Minus 17 plus 19, it becomes 2. So that is summation FIDI is equal to 2. So the next column is frequency with DI square. So multiply 2 into 9, 18. Next we have 3 into 4, 12. Next we have 5 into 1, 5. Next is 0. Next we have 3 into 1, which is 3. Next we have 5 into 4, which is 20. Next 2 into 6, which is 12. Take the summation of this column, that is summation FIDI square is equal to, when you add all these value, you will get the value as 76. Now let us use the formula to calculate variance and standard deviation. So that is variance is equal to h square divided by n square into n summation of FIDI whole square minus summation FIDI whole square. So this is the formula. Height is actually 30 square by 30 square, and here it is 30 into 76 minus 2 square. So cancels, you will get the value as 2280 minus 4, that is equal to 2276. So this is your sigma square, which is variance. So if you want standard deviation, it is sigma, which is square root of 2276. So therefore standard deviation value, it is equal to 47.707. So this is the standard deviation. We can also calculate the mean, because mean is nothing but x bar. So usually to calculate the mean, we used to calculate FIXI divided by n, or we used to calculate adding all the observation divided by n. So here we will use the formula for mean, that is x bar is equal to a plus summation FIDI divided by n into h. So this is the formula used to calculate the mean. Now what is the assumed mean we have taken? That is 105. So 2 divided by 30 into 30. So you can cancel. You will get the value as 105 plus 2. So 107 is the mean. So we have calculated the mean as well as standard deviation. Next problem. Find the mean and standard deviation using shortcut method. 0 to 10, 5, 10 to 20, 8, 20 to 30, 15, 30 to 40, 16, 40 to 50, 6. So let's see in a tabular form. I have taken the class interval and I have taken Fi. So when you add it, the value you will get n is equal to 50. Now let us write the midpoint of each interval, that is 5, 15, 25, 35, 45. Now let us take the deviation. Let me take assumed mean as 25. I will take A is equal to 25 and height of the class interval is 10. So here deviation becomes xi minus 25 divided by 10. So subtract each number from 25 and divide it by 10. So what is the deviation you will get? 5 minus 25 is minus 20. Minus 20 by 10 is minus 2. Similarly, you will get minus 1. Here you will get 0. Here you will get 1 and here you will get 2. Now let us take squaring of this. 4, 1, 0, 1, 4. Now first let us multiply Fi into Di. Next we will multiply Fi into Di square. So when you multiply Fi into Di, 5 into minus 2 minus 10, 8 into minus 1 minus 8, 0, 16 and 12. So these are the values. So let us write minus 10 and here it is minus 8, 0, 16 and 12. So when you add it, summation FIDI the value you will get it as 10 because you have both negative and positive. When you add it, you will get it as 10. Next, let us take Fi into Di square. So 5 4s are 8 1s are 15 0s are 16 1s are 6 4s are. So let's take it as first is 20. Next is 8 1s are 8. Next is 0. Next we have 16 1s are 16. Next we have 6 4s are, which is 24. So take the summation of this Fi Di square. The value you will get it as 68. So let us calculate the variance or standard deviation. So variance, that is sigma square, is equal to, you have h square divided by n square into n into summation Fi Di square minus summation Fi Di whole square. Okay. Now h square, so therefore 10 square by 50 square into 50 into. So it is 68 minus 10 square. So here you will get the value as 1 by 25, and when you multiply, the value is 3400 minus 100. So you will get the value as 3300 divided by 25. So when you cancel, you will get sigma square is equal to 132. Now to calculate the standard deviation, sigma is square root of 132. So the value will be equal to 11.489. So this is the standard deviation which we have calculated. Next we will calculate the mean. So to calculate the mean, that is x bar, we have a formula. X bar is equal to a plus summation Fi Di divided by n into h. So assumed mean we have taken it as 25 and Fi Di you got it as 10. N is actually 50 and it is 10. So when you cancel this, this is 10 5s are 5 2s are 25 plus 2. So the value is 27. So therefore the actual mean is 27. Next is coefficient of variation. So coefficient of variation is nothing but CV. It is given by the formula sigma divided by x bar into 100. So here sigma denotes the standard deviation and x bar denotes the mean of the observation. So to calculate CV, we can use this formula. Here mean cannot be equal to 0. Why this is coefficient of variation is used? Because coefficient of variation is used for comparing the variability or dispersion of two series. So when you are comparing the series or any data of any two datas, coefficient are used to compare the consistency or a dispersion or variability of any data. The series having greater CV is said to be more variable than the other series. The series having lesser CV is said to be more consistent than the other series. So more consistent means we can believe the data. So next one, the series having lesser CV is said to be more consistent than the other series. Consistency means we can rely on the data. So when you are comparing two or more datas, the coefficient of variation takes a major part where you can observe the variable or dispersion of observation so that you have decide which data or which series is more consistent. Suppose, let me take an example. Let me take any standard deviation of it is 10 and mean is equal to some 25. How to calculate CV? CV is equal to sigma into x bar into 100. So that is 10 divided by 25 into 100. So we can cancel. So like this we can form the coefficient of variation. Suppose mean is not given, through the help of sigma and CV we can calculate the mean, or standard deviation is not given means whenever coefficient of variation and mean is given, we can interchange the value to calculate the standard deviation as well as the coefficient variation. So using this formula we can find an unknown variable, whether it is standard deviation or a mean or the coefficient of variation. Let's take few problems now. Coefficient of variation of two distributions are 60 and 70 and the standard deviations are 21 and 16 respectively. What are their arithmetic means? We need to calculate the arithmetic means of two series. So let me take C1 and C2, sigma 1, sigma 2. So coefficient of variation, let me take it as 60 and another one is 70. And standard deviation is 21 and here it is 16. I need to calculate the mean of these two datas. We know the formula, that is CV is equal to sigma divided by x bar into 100. So using this formula, for the first one we can write 60 is equal to 21 divided by x bar into 100, or x bar is equal to 21 by 60 into 100. So when you calculate, the value will be equal to 35. So this is for the first case. Let us see for the second case. We have CV is equal to sigma. Again here also we can use the same formula, x bar into 100. Or if you want x bar, it is sigma by CV into 100. So sigma is 16 here, CV is 70 into 100. So dividing and multiplying, you will get the value as 22.85. So this is the coefficient of variation. So if you want to compare here, we studied that the coefficient of variation having greater CV is more variable, and which is having lesser CV, which is more consistent. So we can say the second one is more consistent, the first one is more variable. Next question. The following values are calculated in respect of heights and weight of the students of a section of class 11. So mean and variance are given, height and weight is given. So now here we are supposed to compare these two quantities. So to compare the quantities, I need coefficient of variation. But coefficient of variation means I need x bar as well as sigma. Sigma means I need standard deviation, but they have given the variance. Let us find the standard deviation for both first one and second case. So for case 1, standard deviation, that is sigma, is equal to square root of 127.69. So you will get sigma value 11.3. Next we will calculate CV for this. CV is equal to sigma by x bar into 100. Now this is 11.3. So 162.6 into 100. So here CV is equal to 6.95. Let's calculate the standard deviation for the second case. So when you calculate this, 4.81. Now let's calculate CV is equal to sigma is here 4.81. So it is 52.36 into 100. So solving this value, the value is 9.18. Now here this is about heights and this is about weights. So by observing these two data, what we can conclude? Here the CV of heights is lesser than the CV of weights. That means, so therefore we can conclude the weight shows more variability than the height, or we can conclude the height is more consistent than the weights. So the next question is, an analysis of monthly wages paid to workers in two firms, A and B, belonging to the same industry gives the following result. So that is the data for firm A and that is the data for firm B. So here number of wages earners 586, 648, mean of monthly wages 5253, 5253. Next here it is variance of the distribution is 100 here and 121 here. So what are we supposed to calculate? Which firm A or B pays larger amount as monthly wages? Which firm A or B shows greater variability in individual wage? So here that is we need to calculate the coefficient of variation. First let us find that amount of monthly wages of firm A as well as firm B. So amount of firm A. So this is equal to 586, and so when you multiply this, the value is equal to 30,78,258. Similarly, let us calculate the amount of firm B. So amount of firm B is equal to, so 648 into 5253. So the value you will get it as, it is 34,03,944. So these are the amount of firm A and amount of firm B. Now they have asked you a question, which firm A or B pays larger amount as monthly wages? So calculate the amount here. So which is having the larger amount? So clearly firm B pays larger amount. So this is the first case. Next, they have asked you which firm A or B shows greater variability in individual wages. So we have here mean as well as distribution here. So let us calculate the CV. So second one, so CV of firm A. So that is sigma by x bar into 100. Again, let us calculate CV of firm B. So that is also sigma by x bar into 100. So now here they have given the variance. They have not given the standard deviation. We know standard deviation is the square root of the variance. So here this is actually square root of 100, which is 10, and here it is square root of 121, which is 11. So for the firm A it is 10, for the firm B it is 11. So it is 10 divided 3. So that is 5253 into 100. And here it is equal to 11 divided by 5253 into 100. For the first one, you will get the value as 0.19. For the second one, you have the value as 0.20. I have taken only the first two decimal. So according to the CV of the series having more value is having greater variability. So here it is 0.19 and here it is 0.20. So therefore what I can say, firm B is more variable than firm A. So the next question we have, the following is the record of goals scored by team A in a football session. Goals recorded is 0, 1, 2, 3, 4 and number of matches is 1, 9, 7, 5, 3. For the team B, mean number of goals scored per match was 2 with a standard deviation 1.25 goals. Find which team may be considered more consistent. So here they have given the mean as well as standard deviation for the team B. That means we can calculate the coefficient of variation. But they have not given mean as well as standard deviation for the team A. Let us calculate it using a tabular method. So here we have the table Xi, Fi. The column which we needed to calculate mean and standard deviation is here. So Fi Xi is, so 0 ones are 0, 9, next 14 we have, next 15 we have, next 12 we have. So let us see the next column Fi Xi square. That means you have to square this then multiply with Fi. 0 square into 1. So you will get it as 0. 1 square into 9, 9. 2 square into 7, that is 4 sevens are 28. Next we have 3 square into 5, that is 45. Next 4 square is 16, 16 threes are 48. So when you add this, you will get the value n is equal to 25 here and here you will get the value is equal to 50. And there Fi x square, if you add you will get the summation as 130. Now let us calculate the mean and standard deviation. So mean is summation Fi Xi divided by n. So 50 by 25, the mean value will get it as 2. So the next one is standard deviation. Standard deviation is summation Fi Xi square minus summation Fi Xi by n whole square divided by n. So this is the formula. So here now we have summation fi x square is 130 minus 50 by 25, that is 2 square you will get, divided by n is again 25 under the square root. So when you calculate SD, you will get the value as square root of 1.2, which is 1.09. Now we need to calculate which team may be considered as more consistent. So CV of A is standard deviation 1.09 divided by mean is 2 into 100. Next, CV of B is equal to standard deviation is 1.25 divided by 2 into 100. So by observation you can see CV of A get less value than CV of B. So they have asked you which team is more consistent. So since the coefficient of variation of team A is lesser than team B, we can consider team A as more consistent. So in today's session, we have learned a shortcut method to calculate the standard deviation as well as mean for the given data. Also, we have studied about the coefficient of variation, that is comparison between any two data to recognize which is more consistent or which is more variant. So, we'll meet you in the next session with the new chapter. Until then, keep watching, keep learning, keep exploring. Thank you.